Good morning. Today I'll be presenting Module 2, Moderated and Mediated Regression Models. Basic regression models give us an understanding of the general relationships between variables, primarily the ability to utilize predictor variables to determine the values of an outcome variable. While this is indeed useful, these basic regression models are limited in their ability to define the interplay between predictor variables and themselves. In real life, there's no clear distinction between multiple measures. There will usually be more complicated interactions between predictor variables that augment the relationship between a predictor and the outcome. Moderated regression allows us to model this complicated interplay. Using the example of statistical knowledge of college students, I will demonstrate how a moderator, in this example sex, gives us insight into how a third variable, as defined by Cohen and Cohen, will have a significant impact between the statistical knowledge and test score values. Before running the analysis, a few things to note. Testing for a moderated model includes running the main effects of the predictor and moderator on the outcome, as well as running an interaction effect of the product of both predictor and moderator. Basic regression models are additive, meaning that we only measure the effects of each predictor individually on the outcome and hold each other predictor constant when running our analysis. In a moderated model, we would also take into account the product of both the predictor and the moderator on our outcome, detailing the possibility of an interaction effect between variables, meaning that the relationship of our predictor and outcome is affected by the value of the moderator, as detailed by Barron and Kenny in 1986. Before running our model, we center our predictor and moderator variable. By centering our variables, we eliminate the non-essential collinearity that is inherent in variables with different scales, and we are able to interpret our results clearly, as all variables are on the same scale. After running our moderated model, we observe the following. We have a significant interaction effect. This is most important finding of the summary table. This effectively states that across different levels of our moderator, the relationship between our predictor and our outcome will be affected. In this case, we see an antagonistic relationship. This is noted because the coefficients of our main effects are a different sign than the sign of the coefficient of our interaction. Our diagnostic plots show that there is one value, 500, that is of interest in the residual versus leverage plot. A separate evaluation of the model with this value omitted did not change either the values of the estimates nor did it affect the p-values of the main effect interaction. Thus, this value was kept in the analysis. Our simple slopes analysis shows us that the value of our slopes of the relationship between centered statistical knowledge scores and test scores at different values of our sex variable. We see that at different values of our sex variable, our slope of the line changes dramatically. This is one of the key indicators of an interaction effect between our predictor and moderator. Our interaction plot reinforces this belief. We can clearly see an interaction in our variables. In addition to this interaction effect, we can draw these observations. The crossing of the two lines means that our interaction is a disordinal interaction, which means that the changing values of statistical knowledge affects the rank order of the high and low scores across both levels of the sex moderator variable. Where moderation allows us to see the influence of a third variable on the relationship between a predictor and outcome variable, mediation gives us a causal link between our predictor and outcome variable when taking into account the presence of the third variable. A distinction between both models cannot be understated. A moderated model shows us how at different levels of a third variable, the relationship between two variables changes, while in a mediated model, we are demonstrating that the presence of a third variable causes the effect between statistical knowledge and test scores. McKinnon points out that the inclusion of a mediator variable improves our understanding of this relationship because we say that it is part of a causal path, x to m to y. As noted in both McKinnon and Barron-Kenny, testing for mediation involves a three-step process, testing for the significance of the links between the predictor, mediator, and outcome. After running the three-step mediation analysis, we can see the following. Our A, B, and C prime path are all significant. This means that there is a significant mediation effect present. In step 3, we see that our stats knowledge variable is still significant with the inclusion of the mediator. Thus, we see a partial mediation effect instead of a full mediation. Diagnostic plots all look good for step 2 and 3. In order to test the significance of our mediated model, we utilize a simple Sobel test. The simple Sobel test, as defined by Preacher and Hayes, computes our A-B product by the standard error of our model. In this case, our simple Sobel test generates a significant result at the p is less than 0.05 level. This result, while encouraging, is not definitive as a declaration of a causal link between variables. Preacher and Hayes note that since the product of AB has a normal distribution only with large sample sizes, the effect size of the Sobel test is small. To counteract this, we run a bootstrap analysis on our model. By bootstrapping our analysis 1,000 times, we see that not only are our direct and indirect paths significant, but we still have the partial mediation effect that we originally ran. The increase in sample size via bootstrapping increases the effect size and gives us a greater confidence to establish a causal link between our variables. While bootstrapping is an effective way to gain confidence in our findings, there are still some issues that need to be accounted for. The biggest issue is at what point in our confidence intervals of our bootstrap model do we begin to question the significance of our finding. A sensitivity analysis of the bootstrap mediation model gives us the region at which the predicted mediated effect is equal to 0, the point at which we should begin to worry about a relationship between our residuals of the mediator and the outcome. For this model, the rho value at which our average mediated effect will equal 0 is 0.15. Moderation and mediation gives us a greater insight into how the third variables affect the relationship between the predictor and outcome. It is important to note that these models are merely a small view into the complex interactions between variables in real life. This analysis of moderation and mediation is a reminder of the complexities of real-life interactions between variables, as well as an understanding that by modeling these complexities, we see a very nuanced relationship between our variables.